In today's lecture, we'll start with the Unit 4, that is transformer. Unit 4 is divided into two parts. One is transformer and one is measuring instrument. So let's discuss in detail about the transformer. According to you, what is transformer? Basically, transformer is a device which is used to change voltage level. Okay, which is used to change voltage level, but there is one condition, that is without change in frequency. What is the condition? Without change in frequency. So transformer is a device which is used to change voltage. Okay, now the question arises, why there is need to change the voltage. I'm telling you the very practical example. What is that example? That in this case, suppose you are using a socket in your home, right? You will use this kind of socket, correct? And that socket is of how much volt? That is 220 volt, right? So in this 220 volt socket, you are using a charger of your phone. Do you know how much phone needs battery? Hmm? Phone needs how much voltage? Have you seen any charger? That is 5 to 15 volt. So you are giving how much voltage? 220 volt, but your phone needs how much voltage? That is only 5 volt. So now here you need to decrease the voltage. So in your charger there is a device, that is transformer, which is used to decrease the voltage. Okay, so now the question arises, like we are using transformer in our charger. The main thing why we are using the transformer, have you listened about the Punjab Bhakra Nangal Dam? In Punjab, there is a Bhakra Nangal Dam. Have you listened about it? Hmm? It is basically an hydroelectric power plant. Here, electricity is generated through water. And the voltage across this one is voltage. In India, the generation voltage is 11 kilovolt always. Or we can say 11,000 volt, right? So in India, electricity is generated always at 11 kilovolt. Now the thing is, suppose we'll want to transfer the electricity from Punjab to Haryana, or we can say Punjab to Delhi. As you can see that this is a very long distance transmission. Yes or no? This is a very long distance transmission. So what happened in this long distance transmission, there are lots and lots of losses. And do you know the formula for the losses is I square R. So what we want to decrease the losses. To decrease the losses, we must decrease the current, correct? So we'll have the formula P is equal to V multiplied by I. Here power is constant. If we want to decrease the current, then voltage must be increased or decreased? Tell me. If we want to increase, right? If we want to decrease the current, then voltage must be increased. So here in Punjab, we'll use one transformer, and technically this transformer is known as step up transformer, which is used to increase the voltage. Like electricity is generated at 11 kilovolt, it may be updated, like it may be increased up to the voltage up to 440 kilovolt. Got it? Now from Punjab to electricity comes over Delhi. Now the Delhi voltage is how much we are getting? That is 440 kilovolt, right? So 440 kilovolt is so high voltage. As you know, at our homes we are using how many voltage? Only 220 volts, correct? At our home we are using only 220 volts. So see, 440 voltage is so kilovolt is high voltage. So what we need to do, we need to decrease the voltage. Suppose the voltage is decreased up to 11 kilovolt. So here at this particular point we are using the step down transformer. Now electricity is need to further transmit like North Delhi, East Delhi, West Delhi, South Delhi. At our homes we are getting 220 volts, so further 11 kilovolt to 220 volt is transmitted. So can you tell me which transformer will use over here, the step up transformer or the step down transformer? Step down, right? Step down transformer from 11 kilovolt to 220 volt. Okay, clear? So now you got to know why there is a need of changing the voltage. See, if we can't change the voltage, if there is no transformer, then you can't use your phone. We won't be able to get electricity, right? Because in Delhi we can't generate so much high amount of electricity na. Punjab is a Bhakra Nangal Dam, that is a hydroelectric power plant. So that hydroelectric power plant generates a lots of amount of electricity. You know, in India 70% of the electricity is generated through hydroelectric power plant only. Okay, now after this, the basic construction or the basic structure of the transformer or the principle of operation. Like this is a transformer, generally will use iron material or will use silicon steel material for this. Okay, basically we'll have two windings. Okay, this one is known as the primary winding and this one is known as the secondary winding. Okay, here secondary winding is connected across the load. Load means at our home appliances, like we are using bulb, electricity, that is a load. Means secondary side is connected to the load and the primary side is connected to the single phase AC supply. Okay, means suppose primary side is connected to the government side, ki government side se electricity is coming, and then from the transformer, with the help of transformer, we are getting the electricity at the secondary side. Got it? Clear? Here the prime number of turns is N1 and in the secondary winding will have number of turns is N2. Now see, here the primary winding is connected to the AC supply. Here the voltage is V1, number of turns is denoted by N1, all the primary turns are denoted by 1 and all the secondary turns are denoted by 2. Here the number of turns is N2. Here the voltage and current flowing in this is I1, current flowing in this would be I2, and due to this current, flux is induced. You know, whenever there is a flux, whenever there is a current, then flux will be there and that flux will be induced in the material, right? So after this there is a EMF. As you have studied in 12th class also, there are two types of EMF. Okay, what are those two types? Can anyone tell? One is the self-induced EMF and another one is the mutually induced EMF. Okay, self-induced EMF means if we are giving supply to the primary winding and automatically EMF even is induced in the primary only. Okay, like suppose I'm giving you example, you have money and you are buying gift for yourself, so that is your self love, right? And if you have money and you are buying gift for your friend, so that is your mutual love. So similarly, if we are giving supply in the primary and we are getting EMF in the primary only, that is self-induced EMF. And another thing, if we are getting getting supply in the primary but EMF is induced in the secondary winding, that is mutually induced EMF. Got it? So this one, primary winding supply, primary EMF, that is even self-induced EMF, and we are giving supply to the primary and automatically EMF is induced to the secondary, that is known as mutually induced EMF. Now the question arises that how this EMF is induced, on which principle it based. So basically it is based on Faraday's law of electromagnetic action. What does Faraday states that, as you have studied in machine also, that E is equal to minus N d phi by dt. What do you mean by d phi by dt? phi by dt means change in flux with respect to time. Okay, d phi by dt means change in flux with respect to time. So he said that if there is a change in flux, then EMF will induced. If there is no change, then EMF will not induce. Correct? So now as you know that current is there. So current depends on flux. If current is changing, then flux also keeps on changing. Yes or no? So if current is changing, then flux also keeps on changing, right? If flux will change, then EMF will induced. Now on the second part, if we'll provide the DC supply, in this current is changing. Hmm? Current is changing? No, na. If the current is not changing, then flux also remains constant. If flux is constant, then there will be no EMF induction. So no EMF induction means no transformer will be there. Basically transformer always works on AC. This is a very important question for the Viva point of view. Generally they'll ask in the Viva that why transformer works on AC, or sometimes they'll ask transformer works on AC or DC. So when I'll take the Viva, so maximum students will say ki ma'am transformer convert AC to DC. No, transformer always works on AC, it never works on DC. Now you know the logic of that. Now after transformer EMF, like how much is the EMF induced in the transformer? EMF induced in transformer. So you must know na कि transformer में कितनी EMF induce हुई है. Like we have studied the EMF induction in machine. Remember that was how much? What was the formula? E is equal to PNZ phi by 60A. Similarly, how much is the EMF induced in the transformer? That we must know, and that is E is equal to 4.44 NF phi M. Okay. If there is E2, then that will depend on number of turns N2, and if there is E1, then that will depend on number of turns N1. Okay, then after that we'll divide it. So if we'll divide these two EMF, then this will cut it down, right? So what we'll get? We'll get E by E1 is equal to N2 by N1 is equal to, if E2 is there, then V2 by V1. Then in that case voltage is there, then current will be opposite. As you know, P is equal to VI. If voltage increases, current decreases, right? So if V2 is there, then I1 by I2 is equal to K, and that is known as transfer ratio. Based on this formula, a numerical will definitely come in your exam. Okay, write it down. Okay, after this, if N2 is greater than N1, then in that case V2 will be greater than V1. If the number of turns in the secondary side is greater, then voltage across the secondary side is greater only. Okay, so if N2 is greater than N1, that would be step up transformer or step down transformer? Tell me. Step up transformer, right? If suppose N1 is greater than N2, then V1 would be greater than V2. Then in that case, that would be the step down transformer. Okay, clear? Now based on this, we'll have another formula that can ask two numerical, that will have phi m is equal to Pm multiplied by A. What is A over here? A is the area. What is Bm over here? Bm is the maximum flux density. And what is phi m over here? Phi m is the maximum flux. Okay. So what is the unit of flux? That is Weber. Weber is denoted by W. And what is the unit of area? That is meter square. What is the unit of maximum flux density then in that case? That would be Weber per meter square, right? And 1 Weber per meter square would be equal to 1 Tesla. So you will get this part in the form of numerical. See, this is your paper question. But they said a single phase transformer has a core whose cross sectional area is 150 centimeter. Means area is given 150 centimeter square. To convert it into standard unit, that would be 150 10 raised to power minus 4 meter square. At a maximum flux density means Bm is given, that is 1.1 Weber per meter square. From a 50 Hz supply means frequency is given 50 Hz. If the secondary winding has 66 turns, N2 is equal to 66. Determine the output in kVA. Output means you need to calculate output power. kVA means the unit is apparent power now. So calculate S. When connected to a load of 4 ohm impedance means RL is equal to 4 ohm. Neglect any voltage drop in the transformer, right? So first of all, you tell me how will you get it. As you know, the EMF formula is equal to 4.44 NF phi m, right? 4.44 we know. If we'll take E2, then it would be N2 because N2 is given. 4.44 we know. N2 is the number of turns 66. F is the frequency 50 Hertz. Phi m we don't know, right? So how can we get phi m? As I told you the formula that phi m is equal to Bm multiplied by area. Bm is 1.1 and area is 150 into 10 raised to power minus 4. So from here we can get the value for phi m. After getting this, we'll get E2. Yes or no? S is equal to, we can say V2 I2, right? But for that we need I2. V2 or E2 is same, that we have calculated. As you know, V is equal to I into R. So voltage we know, V2 and E2 is same thing. Okay, don't get confused over here. So whatever the value of V, we'll put it here. I we need to calculate and R is given 4 ohm. So from here we can get I, we can substitute I over here, then we'll get the apparent power. Now see the next thing, that in the transformer will have some kind of losses, right? So as you can see that in the transformer we'll only two things. One is the material, that is core material. Another thing will use the winding, and that winding is of copper material, right? So losses is here further divided into two category. One is the core loss and another one is the copper loss, right? So core loss is denoted by PC and copper loss is denoted by PCU. Core loss, or we can say iron loss also, because the material which we are using, that is iron loss, or that is denoted by Pi. Core loss or iron loss is further divided into two losses. Further, one, there is a hysteresis loss and another one is the eddy current losses. Okay, so did you remember the hysteresis loss that you must have studied in class 12th also? Hysteresis loop, you remember? Acha, ठीक है. You don't need to go into so detail, just you need to write down the formula for the hysteresis. H is equal to KH F into M into 1 point. Bm की power is 1.6. What is KH over here? KH is the hysteresis constant. Okay, what is V? Maximum of the student, V voltage, no, V is the volume of material. What is F over here? F is the frequency and Bm, as your Bm is the maximum flux density. Okay, write down this one. Next one is the eddy current formula, is equal to K E F square T square square M. As you can see, Ke is the eddy current constant, right? where V is again the volume of the material, F is the frequency, the thickness of material, and Bm is same, maximum flux density. So you just need to remember the formula. Okay, here. So now how can we reduce the hysteresis losses, or how can we reduce the eddy current losses? If we'll use lamination in the material, that will reduce eddy current losses. If we'll use silicon steel material instead of iron material, that will reduce losses. Now see how will we do the lamination. Like suppose we'll have a long material of silicon only, cut it into thin slices and then combined it. So that would be the form of lamination. Okay, lamination, write down, lamination is done to reduce eddy current losses, and silicon steel material is used to reduce. Okay, now the efficiency of transform. Okay, what is efficiency? Efficiency is basically denoted by eta. And if I'll say you, like I'm giving you an example, that suppose I give you 5 questions in the homework, and from that you will be able to do 4 questions. Okay, so in this case, how much would be your efficiency? Tell me. From 5 you will be able to do 4. How much is your efficiency? 80%. So how did you calculate efficiency? That 5 question which I gave you, that is your input. 4 question you will be able to solve it, that is your output. Correct? So efficiency is always output power divided by input power, and it's always in percentage, as you said percent, so multiplied by 100. Okay, so now the next thing, can we write down input power as output power plus losses? As you have done 4 question in the output plus 1 question is the loss, so whatever you will give it, like input energy will be converted into output, plus there will be definitely some losses, right? 5 question, that is your input, 4 question, that is your output that you have done, and 1 question is the losses. So can we get this formula that input is equal to output plus losses? So if input is equal to output plus losses, we'll write down output in terms of output power only. Okay. Now, as you know, the active power formula is what? V2 I2 cos phi 2. Why I'm writing 2? Because it's the output side. Output side means the secondary side. And as you know, secondary side is denoted by 2. Again, the output power means V2 I2 cos phi 2 plus losses. Losses means, as you have studied, Pi plus PCU multiplied by 100. So this is the formula for the efficiency, right? Tell me, any doubt up to here? Now my question is, if instead of giving 5 question, I gave you 100 question or 500 question, so your efficiency will remain same or it will change? If I gave you 500 question in your homework, will still give 80% efficiency? Oh, no. So that means efficiency also depends on load. If I increase your load, then maybe your efficiency increases, or maybe your efficiency decreases, right? So load always depends on current, and load is denoted by X. So wherever the current is there, multiply X, multiplied X, and here PCU is what? I square R, right? So here the current would be how much? X square only. Got it? Okay, one numerical based on the efficiency. Efficiency is the most important topic, and there is a maximum chances that you will get one numerical based on efficiency. Again, this is your paper question. They said in a 25 kVA S is equal to 25 kVA, means 25,000 VA. This they'll give it like this, that is V1 and that is V always. V1 is 2000, V2 is 200 volt. Transformer, the iron and full load copper losses, means iron losses Pi is given 350 watt and copper losses PCU is 400 watt. Find the efficiency at unity power factor. Unity power factor, as you know, cos phi is equal to 1. First they said calculate efficiency at full load, means x is equal to 1, right? So I'm writing the formula, x into I2 cos phi 2 divided by x V2 I2 cos phi 2 plus Pi plus x square Cu, right? So x is 1, right? V2 I2 power, apparent power is Vi now, V2 I2, so we can directly write down 25,000. There is no need to calculate current, okay? Whenever they'll give you, they'll always give you the apparent power, directly write down the value. Cos phi is 1, again 1 into 25,000 into 1 plus Pi is 350 plus 1, copper losses 400 multiplied by 100, right? So this is efficiency for full load. Similarly, can you get efficiency for half load? Half load means x will be 1 by 2. All the things will be same. Okay? Can you get it? Now they are asking determine the load for maximum efficiency. Basically, for maximum efficiency, there is one condition, that if iron losses is equal to copper losses, then that would be maximum efficiency. Okay, so in this case, iron losses, that depends on load also, as I told you. Pi is equal to x square PCU. So x value will how much? Root of Pi divided by PCU. Now see, in the question they are asking determine the load for maximum efficiency, means they are asking the x value, Pi value you know, PCU value you know, so you'll get the x value, right? This question is complete.